Okay, this is number 57 in the back of the text, in the back of chapter 16. Now, this is boiling point elevation, and this is freezing point depression. Those are the equations. The book doesn't necessarily put in N. I think N is very important, and I'm going to show you why. N represents the number of ions that the particle forms in solution. For instance, potassium chloride will form potassium ions and chlorine ions. So that's 2. So N would be 2. And magnesium chloride, N would be 3. Potassium nitrate, N would be 2. Now, glucose does not ionize in water. So it's one particle there, and in solution it would be one particle there. So with glucose, N would be 1. So if the substance that's dissolving, forming the solution, doesn't form a solution, it doesn't ionize. Well, it can form a solution. Sugar can certainly form a solution. But if it forms a solution and does not ionize, then N is 1. Okay, now, the question is, which one is going to have a higher boiling point? Seawater or distilled water? 1 molar potassium nitrate or 1.5 molar potassium nitrate? 0.1 potassium chloride and 0.1, that's molar, magnesium chloride. Now, the Kf and Kb is for the solvent. Let me see if I can get that here. I think it's going to be K, if I recall correctly, Kf is 1.86 and Kb is 0.52. This is for water. If it were benzene or carbon tetrachloride or ethyl alcohol, it would be different K values. These are the constants for for that solvent. Okay, so this is what we're looking for. We're looking at this. Okay, we're looking at this. So, seawater has salt in it. Distilled water does not. So the salt water will have a boiling point elevation. Distilled water will freeze or boil at 100 degrees Celsius. That's distilled water. Pure H2O has a boiling point of 100 degrees Celsius. This would be the elevation. It has no elevation. Has none. Okay? Has none. N would be 0. There's nothing there. There's nothing ionized. There's no salts. So N is 0. So the increase would be 0. So it would be 100 degrees Celsius would be the boiling point. So that would be higher. Look at B. You see that B, you're comparing same salt, but you're comparing 1.5 moles to 1 mole. Which one's going to have a greater number of particles? This one. That will have a greater total number of particles. Remember, it's the number of particles that determines the elevation or the depression. For instance, if I'm comparing two different salts with the same molality, they could have the same boiling point elevation or freezing point depression. This is what's significant. That's what's significant. So for this one here, N is 2, right? N is 2 for both. KB is 0.52, but M for this one is 1, and for this one is 1.5. So the greater elevation would be this one. Okay? The next one is at 0.100 molar. I apologize. Does it say molal or molar? 57. Yeah, molar. Okay. So this would be, you're comparing 0.1, same KB, water, both water, but look at this. N for this is 2, but N for this is 3. So that would be a higher boiling point elevation because of the number of ions, okay? The number of ions. So it would be seawater, it would be 1.5 molar potassium nitrate and 0.1 molar MgCl2. Now there are other videos which explain what I'm going to try to explain briefly. So I'm doing this problem with the understanding that you know the difference between molarity and molality. So moles over 1 kilogram of water, that's molality. Moles over 1 liter, that's molarity. Small m, molality. Large M, molarity. This is used for water, liquid water near the freezing point, and liquid water near the boiling point. This is used for water at room temperature because if I do all my experiments with molarity in a lab near or around room temperature, 25 degrees Celsius, the volume of 1 liter is 1 liter. But if it gets colder, the volume changes. It may not be 1 liter, it may be less than a liter or more than a liter. Okay? So the volume is temperature dependent because of density changes. Water has a density of 1 gram per milliliter at 4 degrees Celsius. Less than that, the density decreases. Greater than that, the density decreases. So the reason you use molality with freezing point depression, boiling point elevation is because 1 kilogram stays 1 kilogram regardless of the temperature. But 1 liter, the volume will change because density is temperature dependent. So you're only using this at one temperature, room temperature 25 degrees Celsius. This is being used at warm, very warm liquids, 100 degrees Celsius, or very cold liquids, 0 degrees Celsius. Okay? So that's problem 57. We're off.